Okay, welcome back. This one should go faster because I did a little bit of the work ahead of time. I apologize. The other one took so long. Again, I'm primarily just going to give the answers, but I will work two problems. Again, the example problem I've already worked for you, I'll walk through again. And the problem, one of the ones that gives people problems when they do this. I'm going to skip this because I feel by now you should know this. If you don't, please do ask so I can explain that. But again, this is given just by simply looking at the periodic table and the atomic number here. Moving forward, the big deal here, this column over here, the number of electrons to fill the outer shell is not real necessary, but it will help if you're not fully understanding what the valence electrons and Lewis dot structure is. These three columns are just like the ionic practice above. So what I've already done here is valence electrons for carbon. As a reminder, group 1, 2, 3, skip a few. Oops, I said 3. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. And here's carbon in group 4. So it has 4 electrons in its valence shell. Bam. To satisfy the octet rule, how many more electrons does it need? 4. So it's going to have to bind with either one other element that also needs 4, or any number of different elements in order to attain or share those 4. The idea behind the covalent bond, again, is that it's going to share. Hydrogen has, in the periodic table, 1 proton. Therefore, it only needs 1 electron. And in that first shell, we hold up to 2. So how many more does hydrogen need? 1 more to make 2. So 4 plus 4 is 8. 1 plus 1 is 2. These, no matter what element it is, should always equal either 8 or 2. And for the most part, all of these I know will be 8. So you get the number of valence electrons by looking at the group it's in, and you do 8 minus. So you kind of do 8 minus whatever number this is down here. And that's the number you're going to put right here. Okay. So 8 minus whatever number's down there will give you that number. Boy, getting rough at this. Okay, moving forward. So here's the example of oxygen. So oxygen, I looked on my periodic table. It has 6 valence electrons. So I placed them 1, 2, 3, 4, 5, 6. A quick note is by rule, this is kind of a side note, but by rule, you cannot do for a given element, 1, 2, 3, 4, 5, 6, and then have 2 open ones here. You can have an open one if there's only there's less than 4, but generally speaking, remember every side gets 1 before any one side gets another one. Now, this is not a big deal. You don't have to think deep about this, but it tells you why I'm able to do and why I know to do this. That is 2, 4, 5, and 6, as opposed to 1, 2, 3, 4, 5, 6, and have that. Because that's not the way in which the electrons fill the orbital. That was in a couple of the past lessons. I just want to reiterate that. Now, when you're doing Lewis dot structures for bonding, you can make it to your convenience, as I have done here. I put it so that the open ones are facing each other. We know that there was another electron that could fit here and another one that could fit here, just like we did in the ionic bonds. But our point is not ionic bonding. Our point now is sharing these electrons. So I followed the instructions. First, I wrote the symbols. Second, I drew the Lewis dot structure for the valence shell element. There's 6 electrons. Then now we are at the draw the bond structure using the chemical symbols and lines. And that's what I did right here. Okay. So again, according to the video and the lessons that you did, wherever 2 electrons are shared, and one's not going to share, one oxygen will not share its electron without the other sharing his electron, we can just draw a single line to represent that sharing. We can draw a single line to represent that sharing. And so the way that becomes written is O with 2 lines between an O. That's the structural formula. We call this the structural formula, by the way. And this is the actual chemical formula. So there's 2 oxygens, O2 is the answer. So going through all these steps, showing me this, so if I could erase now the green, everything that's in pink, is what you want to have. Oh, goodness, whatever, you get the point. Done. Okay, this would be what you have in your answers. So this is a chemical formula for chlorine, Cl2. Answer for hydrogen and plus a chlorine, when they form a bond, will form hydrochloric acid. This is just chlorine gas. This is oxygen gas. That's the way those are called. This is hydrochloric acid. Hydrochloride. Hydrochloride is another way to say it. For hydrogen and oxygen, that happens to come together in this form. You know H2O, that's water. Here's ammonia, bathroom cleaner maybe. NH3. And then carbon and hydrogen is hydrocarbon. This hydrocarbon happens to be called methane or methane. Okay, those are the answers to the covalent. Again, show me your work and how this happens. I will go ahead now and do, I can do either one of these two. These are probably the ones that you have issue with. I'll do the nitrogen hydrogen. Okay, so real quickly, just in case you may not have had questions, but just in case you did, nitrogen is in group 5. If we look on the periodic table, it's over here. I say group 5. Yep, group 5. We know hydrogen is group 1. So if that's 5, we have, let me go to my number 6 here. 1, 2, 3, 4. And let's go ahead and put the 5th one over here for convenience. Hydrogen, we have a hydrogen atom, draw our symbol, then put our electron dot structure. We know it has 1. So technically then, these are right here. Let me change my one more time. These right here could share. And so now we say 1, 2. Both of those electrons, okay, both this one and this one can be counted for hydrogen. So hydrogen has 2. How many does hydrogen need? 2. Hydrogen's fine. But if we look at the nitrogen, we still have 1, 2, 3, 4, 5 plus one of these, 6. So is nitrogen stable? Nope, he only has 6. So what we actually need to do is put another hydrogen here. Sorry. Another hydrogen here. And with this 1 electron, and now you know as well, now these can share. I'll share yours if you share mine, or vice versa. And so, you know, we're going to have a line here. We can have a line there. And now nitrogen has 1, 2, 3, 4, 5 original, plus the 1 from this hydrogen, plus the 1 from this hydrogen makes 5, 6, 7. Looks like we're going to need 1 more hydrogen. And it has its 1 lone electron. And he says, hey, I got something you might need. And you do. And so these 2 can now share. And so 2 electrons are represented by a single line. So that's NH3. So now let's count all of our electrons for nitrogen. 1, 2, 3. No, I guess I'll do this with the green here. We got 1, 2, 3, 4, 5 original ones, plus 5, 6, 7, 8 shared ones. So nitrogen has a total of 8. And for each hydrogen, all you need is 2. And well, in each of those circles, you can see there are 2 electrons. So each hydrogen is stable. Now, how do we write that? After that is, you can do it one of 2 ways. Nitrogen and just 3 lines to a hydrogen. This is a nitrogen, and that's fine. In triple covalent bond to hydrogen. Oh, I'm an idiot. Sorry. No, I can't delete. See, even teachers make mistakes. That's not the way. It's not a single triple bond. That's what would happen. Could happen between two carbons. My apologies. I wouldn't expect you to know this exactly, although you could look it up. But nitrogen has one, and we can't draw them the same. So I'm going to, one was on the side, one was up here on top, and one was down here on the bottom. There we go. Apologies. So nitrogen in the center, and those single lines represent what? This line represents a pair of electrons being shared. This line represents a pair of electrons being shared. This line represents a pair of electrons being shared. So that's how that would be written. And then, of course, chemical formula is N, and then H3. Okay, hope that helps. Again, today, remember, I'm going to try every day. You have personal medium. If you have questions on this between 1:30 and 2:30, you can pop in by clicking on this link. I'll be available, and you can do voice and or video, and we can share each other's screens if you want to show me something, or I can show you how to do it. Okay, have a good one.